Good evening. I am Anitha, Assistant Professor in the Department of Artificial Intelligence and Data Science. Today we are going to see about rule-based classification. First, what is rule-based classification? Rule-based classifiers is another method for reducing a subject's categorizations. These classifiers establish a subject classification based on a set of if and otherwise rules. The creations of descriptive models normally involves utilizing these various classifiers due to the fact that these criteria are easy to comprehend. If a rule is able to anticipate a certain class, we refer to that class as the rule consequent on the condition that is evaluated using the if keyword if the rule's antecedent. One is feature extraction and then defining a set of rules by selected few features, partitioning by rules. Next classifier that relays on rules have the following characters. The term coverage is used in the field of statistics to refer to the proportions of available data that satisfy the requirements of a certain rules. Rule-based classifiers will often give rules that are not mutually exclusive with one another, which means that several rules may be applicable to the same data sets. There is a possibility that certain records will not be covered by the rules that are generated by rule-based classifiers. The result is linear decision boundaries, but because several rules can be triggered by the same records that are oftentimes for more involved than a decision tree would be. Next, rule-based classifiers are just another types of classifiers which makes the class decisions depending on using various if-else rules. These rules are easily interpretable and thus these classifiers are generally used to generate descriptive models. The condition used with if is called an antecedent and the predicted class of each rule is called the consequent. Next is properties of rule-based classifiers. These coverage the percentage of records which satisfies the antecedent conditions of a particular rule. The rule generated by the rule-based classifiers are generally not mutually exclusive. That is, many rules can cover the same record. These rules generated by the rule-based classifiers may not be exhaustive. That is, there may be some records which are not covered by any of the rules. The decision boundaries created by them are linear, but these can be much more complex than the decision tree because the many rules are triggered for the same record. Rules can be generated either using general to specific approach or specific to general approach. In the general to approach, start with a rule with no antecedent and keep on adding conditions to it till we see major improvements or our evolution metrics, while for the other we keep on removing the conditions from a rule covering a very specific cases. In evaluation metric can be accuracy, information gain, likelihood ratio, etc. Next, rule induction using sequential covering algorithms. Sequential covering algorithms can be used to extract if-then rules from the training set. We do not require to generate decision tree first. In this algorithm, each rules for a given class covers many of the tuples of the class. Some of the sequential covers algorithms are AQ, CN2 and repair. As per the general strategic, the rules are not learned one at a time. For each time rules are learned, a tuple covered by the rule is removed and the process continues for the rest of the tuples. This is because the path to each leaf in a decision tree corresponds to a rule. Rule pruning. The rule is pruned is due to the following reason. The assessment of a quality is made on the original set of training data. The rule may perform well on training data but less well on subsequent data. That's why the rule pruning is required. The rule is pruned by removing conjunctions. The rule R is pruned. If pruned version of R has greater quality, then what are assessed on an independent set of tuples. Next, coming to rules extractions for a decision tree. To classify data where we thought to construct a decision tree using the data used for training, decision classifiers are widely used because their operations is intuitive and they consistently produce accurate results. Huge decision trees are often intelligible. In this part, we examine the process of developing a rule-based classifiers by mining a decision tree for if-then rules. For very vast decision trees, if-then rules may be more initiative to people. Every possible branch from the root node to the leaf node must be converted into rule before the tree can be mined for its rule set. The if else of a rule is formed by logically ending and the root splitting criteria along that path. The rule's consequent is class prediction, which is stated at the starting node. Thank you.